Hi, welcome back. Today I'm going to talk about section 4.1, but I'm only going to talk about a portion of 4.1. So section 4.1 is all about the slope of a line. And I think the first part of this section is going to be pretty self-explanatory and pretty much a review for you. So what I want to talk about is the second part of this section, which actually talks about difference quotients. Now you will have seen these before at one point, but it may have been a while. And it may have been one of those things that you really didn't like very much, so maybe didn't stick, because it tends to be one of the things that students struggle with. So I want to go through it again so that maybe this time it's a little less painful and makes a little bit more sense. But before I do this, so what we're talking about, for example, I'm going to talk about example 8. On page 268 of your text. And what this says is, if f of x equals x squared minus 4, find f of x minus f of a all over x minus a. Now, this arrangement, this thing that I just wrote down, is the difference quotient. For the function f of x equals x squared minus 4. Now, this difference quotient becomes very important in later classes, and the reason we're covering it in this slide, in this section, is if we think about this for just a minute. Remember two ways that we can represent points that are on a function. We can either call them xy's, or we can say, or we know also that f of x and y are the same thing, and a and f of a is also a point on the line. So if we think of this x comma f of x as an x1 and a y1, a specific point on the function, and this fa comma f of a, this point, is an x2, y2, our difference quotient becomes y1 minus y2 over x1 minus x2, which is the slope of a line between those 2 points. So this is Desmos, and what I've got here is the graph of our function, y equals x squared minus 4. And then I just picked 2 points on that function. This point down here is -1, -3, so this would be like x equaling -1. The y that would go with that is -3. And I picked another point, 3, 5, so this would be like a equals 3, and f of a then equals 5. And what we're going to find is the slope of the line between these 2 points. Now, here's the thing. If I move these points, the slope of the line moves. And what we're finding is the average rate of change, or the slope of the secant line between these 2 points. This is called a secant line. It goes between 2 points on a graph. In later classes, specifically calculus, you'll be talking about the slope of a line tangent to a graph. And that happens if we move these points closer and closer together until the second point is right next to the first point. The slope of the line begins to approach the slope of the graph. The difference quotient is how you get there. So what we're going to concentrate on today is finding the difference quotient. And there are 2 ways we're going to do this. The first one is with this form. So we're going to go through this one first, and then we'll talk about the second form. All right, so let's talk about what we're actually going to do here. I'm going to start with a new piece of paper. Actually, I'm just going to turn this one over. No, I'm not. Okay, so my function is f of x equals x squared minus 4. And I want to find f of x minus f of a all over x minus a. So what we're going to do is we're just going to replace f of x with its definition, which is x squared minus 4. And we're going to subtract from that f of a, which is a squared minus 4. And we're going to divide the whole thing by x minus a. So all I've done is I've taken what we were asked to find, and I've expanded it using the definition of f of x. Okay, now we're going to simplify. So on the top, I've got x squared minus 4 minus a squared plus 4 all over x minus a. I just eliminated my parentheses and distributed my negative sign through. So now I know that negative 4 plus 4 is 0, so I can cancel that. And I'm left with x squared minus a squared over x minus a. Remember that you cannot cancel something that is added to or subtracted from something else. So what we need to do is factor the top. We've got x minus a times x plus a is how that numerator factors, because that's a difference of perfect squares. If you don't remember that, the AC method will get you there. We're going to divide that by x minus a, and I put that in parentheses to remind myself that it's all one thing, all stuck together. You can't separate it out. And now those two will cancel because they match, they're like factors. And all right, we are left with just x plus a, and that is the answer. That is the difference quotient for the function f of x equals x squared minus 4. All right, now let's look at the other way. So the difference quotient can be expressed in two ways. The second one is you'll be asked to find f of x plus h minus f of x all over h. So to understand this, let's go back to Desmos for a minute. And let's take off these labels. So these are still 2 points. Think of it this way. This first one is f of x. If I think about going from, this happens to be at -1, to 5, I can add a certain number to any x to get to another x. So this point here, this guy, would be f of x. Now, if h happens to be 4, this guy would be at x plus h, and f of x plus h. So we're still just talking about 2 points on a graph. We're just calling one of them x, and the other one x plus h for the x coordinates. So here's what we're going to do. Same thing. F of x plus h is going to be x plus h squared minus 4. That is f of x plus h. You're going to subtract from that f of x, which is x squared minus 4. And then I'm just going to divide by h. We're going to simplify on the top. X plus h squared is x squared plus 2xh plus h squared, do not forget to FOIL that, minus 4. And now distribute our negative sign, and we get negative x squared plus 4. All divided by h. Okay, now we're going to cancel out the things that'll cancel on the top. My x squareds cancel, and my minus 4 plus 4 cancels. And I'm left with 2xh plus h squared all over h. Factor out the h on the numerator. Cancel out our matching term factors. And we're left with 2x plus h. This also is an expression of the difference quotient for the function x squared minus 4. Okay, now your textbook has got an example for using your calculator to do this for specific numbers. Most of the time we're going to be doing it with variables. So I'm actually not going to go through that textbook example on the using technology. We'll use our calculators for other things. Let me know if you have any questions. Feel free, please, to post this to the forum. But if you post to the forum, please give me some indication of what your question is. Something like, I understand how to find f of x. I'm having troubles with the simplification. Anything to give me a hint on where to start so that I can kind of help you out, but I'd like to have a hint. So good luck. You can do this. Just a matter of taking it step by step. And I will see you again soon.